Hi everyone. I recently took the AWS Certified Machine Learning Specialty exam, and I noticed that many of the available practice exams don't cover important newer topics such as SageMaker Data Wrangler and SageMaker Canvas. So to help fill this gap, I created my own practice exam. So in this Udemy course that I created, there is a set of 15 warm-up questions, which I have included here in this YouTube video with full explanation. And then it continues with a full 65 questions practice exam designed to reflect a real test experience. So since this is a brand new course, I will be giving out free coupons. So be sure to grab yours quickly through the link in the description. So question 1. You're analyzing telemetry data from thousands of IoT devices connected via AWS IoT Core. Each device sends temperature and humidity readings every second. The temperature fluctuates around a stable mean, but you're interested in modeling anomalous deviations for help monitoring. Which distribution should you assume for baseline temperature modeling to detect statistically significant outliers? So this is a typical question where you should know the different distributions. So the distributions that you for sure should know are Poisson, normal, uniform, and exponential distribution. The temperature is a continuous variable and it has a stable mean. So with that, you should know that it's the normal distribution. Then you also have the Poisson distribution. So that is used for modeling the frequency of discrete events occurring in a fixed interval. So for example, the number of device failures per hour. Then we have a uniform distribution where all the probabilities are the same within a certain range, which isn't the case here because we have a stable mean. And then finally, we have the exponential distribution. So that is used for modeling the time between events or durations. So for example, the time until a device fails. So I will go over the correct answer. And I will also show the explanation. Question 2. You're a machine learning engineer at a financial institution that processes millions of credit card transactions daily. Your team has been tasked with building a real-time anomaly detection system to identify potentially fraudulent transactions. The dataset consists of numerical features such as transaction amount, time since last transaction, and merchant category codes, with no labeled data available for training. The system must handle high-dimensional data, operate in real time, and detect anomalies without requiring predefined thresholds. Which AWS machine learning algorithm or service should you use to meet these requirements? So what do we need? We need an anomaly detection system. And it's very important that we don't have any labeled data available for training. So the first option, Amazon SageMaker Linear Learner, is not an option. We cannot use it because it's a supervised learning algorithm and it needs labeled data, which is not available. Then for Amazon SageMaker K-means clustering, we can use K-means because it's unsupervised, but it's designed for clustering rather than anomaly detection. So that's also not a good option to use them. Then Amazon SageMaker Random Cut Forest. This is ideal for unsupervised anomaly detection. It is designed by Amazon, and it can be used for numerical data sets and making it a very good choice for real-time fraud detection. And finally, we have Amazon SageMaker Deep AR Forecasting. Deep AR is designed for time series forecasting, and it's not made for anomaly detection, so it's not a correct use case. So the correct answer is Amazon SageMaker Random Cut Forest. Question 3. You are an ML consultant developing an image classification model using Amazon SageMaker to identify different types of flowers in a dataset. You train a convolutional neural network, or CNN, on a labeled dataset with thousands of images across multiple flower species. After initial training, you evaluate the model and notice that the accuracy on both the training and validation datasets is significantly lower than expected. You need to improve the model's performance to achieve better classification accuracy. Which approach should you take to address this issue and improve the model's performance? So what is the problem here? It has a low or not enough accuracy both on training and validation, which means that the model is underfitting. So we need some kind of solution to overcome this underfitting. Increase the learning rates. A higher learning rate may actually cause the model to take large steps and even finding worse solutions, or it potentially skips optimal solutions. So increasing the learning rate is not a good option. Add stronger L1 regularization to reduce model complexity. Actually, the issue here is that the model is underperforming. So if we add regularization, it will be even worse. Increase the number of epochs. This is a valid option because maybe the model just didn't train long enough to find all the patterns that it had to learn. And finally, increase the dropout rate. If we increase the dropout rate, actually this will result in even worse performance because this is something that we do when the model is overfitting, not underfitting. So the correct answer is to increase the number of epochs. Question 4. A machine learning team is developing a fraud detection model that requires real-time feature engineering on transactional data. The data is ingested from multiple sources and stored in Amazon S3. The team needs to create a pipeline that aggregates transactional data hourly, computes features, for example, average transaction amount per user, and makes them available for real-time inference. Which AWS service combination should the team use to build this pipeline? Amazon EMR for processing, Amazon S3 for feature storage and real-time access, Amazon Kinesis Data Analytics for real-time processing, Amazon S3 for feature storage, and AWS SageMaker endpoint for real-time access, AWS Batch for processing, Amazon S3 for feature storage, and Amazon API Gateway for real-time access, or AWS Glue for hourly batch processing, Amazon S3 for feature storage, and Amazon SageMaker feature store for real-time access. So if we take a look, all 4 of the options use Amazon S3 for feature storage. So there we don't have to think about it. And then finally, if we know how we want to access that feature, how can we access it in real time, then we actually already know the correct answer. And S3 is not made for real-time access for the features. Then the second option, setting up SageMaker for the real-time access for the features, also it's not a good option because it requires a lot of manual setup. To use an Amazon API Gateway to get the features also is a lot of setup, and we see that the last answer offers to use SageMaker feature store, and that actually is designed for real-time access of the features. So just by looking at that, we know that the 4th answer is correct. But also, let's go over the first part of the question. So the first one, to use Amazon EMR for processing. It's a powerful tool to use EMR, but it's an overkill for hourly transactional data aggregation, which can be handled more simply with AWS Glue. Then the second one, Amazon Kinesis Data Analytics. It is an option for real-time stream processing. and it's great for continuous data streams, but it's not suited for hourly batch aggregation. And AWS Batch, the one of the third option, it's suited for running batch jobs, but it requires more manual configuration and scheduling than AWS Glue. So from all this, we see that the fourth option, using AWS Glue for hourly batch processing, is the best way to do it. Question 5. A retail company wants to deploy a recommendation model across multiple regions to reduce latency for global users. They need a cost-effective solution that minimizes operational overheads. So the options are to deploy separate SageMaker endpoints in each region, use SageMaker multi-model endpoints in a single region, use Amazon SageMaker Edge on users' devices, or deploy using AWS Lambda at Edge. So the first option seems like a viable option to deploy SageMaker endpoints in each region. So we reduce the latency in each region. It will require some setup and there will be some costs associated, but it's possible. The second one, to use multi-model endpoints in a single region, that's not a good option because we only deploy them in a single region, so we don't reduce the latency for global users. Then using Amazon SageMaker Edge on user devices, this would mean requiring deployment and maintenance on each device, so that's not possible, so that's not a good option. And deploying using AWS Lambda at Edge. Lambda at Edge is great for simple logic or content personalization, but it's not designed for ML inference. So the correct answer in this case is deploying separate SageMaker endpoints in each region. Question 6. A retail company is developing a regression model in Amazon SageMaker to predict customer lifetime value based on historical purchase data. The features include numerical values like total spend and categorical values like customer region. The data scientist notices that the model's performance is suboptimal due to the unnormalized feature scales. The first option. Apply one-hot encoding to numerical features and train with SageMaker's built-in XGBoost algorithm. So, applying one-hot encoding to numerical features, it's wrong. You should only, of course, apply to categorical features, so this option is wrong. Use Amazon SageMaker Data Wrangler to normalize numerical features and one-hot encode categorical features. So indeed, with SageMaker Data Wrangler, we can do this. So this would address the unnormalized features, and also the one-hot encoding of the categorical features is a correct option. So it's a correct pre-processing step. Then option C, convert all categorical features to numerical labels using ordinal encoding and train without normalization. So first of all, it doesn't address the unnormalized features. And second of all, as we see that the example categorical value, like customer region, doesn't have an ordering. So using ordinal encoding for that one is wrong. So this option is wrong. And finally, use Amazon SageMaker Clarify to detect bias in features instead of reprocessing the data. This is clearly a distractor, and this option is irrelevant because it's wrong. It doesn't address the unnormalized features, and this option is clearly wrong. So the second option is the correct one. Question 7. You're a machine learning engineer deploying a binary classification model on AWS SageMaker to predict whether a customer will churn based on their usage patterns. After evaluating the model on a test dataset, you obtain the following confusion matrix results. True positives, 120. True negatives, 800. False positives, 30. False negatives, 50. Your manager asks you to calculate the precision of the model. So you should know that precision is true positives divided by true positives plus false positives. So this is 120 divided by 120 plus 30, which is 80%. Question 8. You're a machine learning engineer training a deep learning model on Amazon SageMaker to classify images. The model is taking longer to train than expected, and you suspect issues with vanishing gradients. You decide to use SageMaker Debugger to monitor and analyze the training process. Which SageMaker Debugger feature would help best you identify vanishing gradient issues during training? Configure a rule to monitor the loss function and trigger an alert if it plateaus. Monitoring the loss function can indicate if training is stalling, which might suggest vanishing gradients. However, such a plateaued loss could also result from other issues like poor learning rates or model architecture. So this is not a good option. Use the tensor collections feature to capture and analyze gradient values in real time. So by examining the gradient values directly, we can confirm indeed if they are vanishing. So this is the best way to directly diagnose vanishing gradients. Third option, enable the profiler to track CPU and GPU utilization during training. This can be useful for diagnosing performance issues, but it doesn't provide insights into gradient values. And finally, set up a rule to monitor data drift in the input features. Data drift is unrelated to vanishing gradients, which are caused by the model's internal optimization dynamics. So this option does not make sense. So the correct one is option 2. Question 9. A data scientist is working with a dataset stored in Amazon S3 containing over 100 numerical features and a binary classification target. The dataset is highly imbalanced and it requires advanced preprocessing, domain-specific feature transformations, for example, a log scaling, and also smooth for oversampling. The goal is to identify the 10 most important features before building a production model. Which solution meets these requirements with minimal overhead? So the first option is to use SageMaker Canvas for pre-processing and identifying the most important variables. So SageMaker Canvas, it's a tool for non-technical users, and we can perform data preparation, and we can also build a model and identify the most important variables. It can also do tasks like handling missing values and scaling, but it lacks the advanced capabilities like the log transformation, and it also doesn't support smooth. So this is not a feasible option. The second option, to use AWS SageMaker Data Wrangler for preprocessing and SageMaker Clarify for identifying the most important variables. So SageMaker Data Wrangler, it's a visual data preparation tool to preprocess data, and we can also do custom transformations. It also supports Smooth for handling imbalanced data. So later we can use the data from SageMaker Data Wrangler, and we can integrate it with SageMaker Clarify to rank the features. So this is a very good option. The third one, use AWS Glue ETL for preprocessing and L2 regularization to identify the most important variables. So AWS Glue ETL, it's a serverless data integration service that we can use for large-scale data processing. It supports also custom preprocessing, but it doesn't natively support smooth, so we would have to write custom code. And also the L2 regularization, it doesn't actually identify the most important variables because the coefficients, they don't go to 0, but they actually shrink, so we cannot use them to select the top 10 features. And then the last option, to use AWS SageMaker data wrangling for preprocessing and use PCA to find the most important variables. So as we said before, we can use AWS SageMaker data wrangler for the preprocessing. However, the PCA, the principal component analysis, it's effective for reducing the dimensionality, but actually it creates new features which are uncorrelated variables. So it's not suitable for actually selecting the top 10 original features in their original form. So the correct answer is the second one. Question 10. A company has an unlabeled dataset containing various customer attributes such as income levels, spending behavior, and regional indicators. The marketing team aims to discover potential customers on social media who resemble those in the existing dataset. Due to limited time, they need a quick and effective method to analyze and structure the available data. Which of the following approaches would best support their objective? So the first option is to use a factorization machine to model the interactions among features and predict similar users. So factorization machines, they can be used to model feature interactions in supervised tasks, for example, in recommendation systems. But as this dataset is unlabeled and there is no target variable, we cannot use this approach. The second one, apply a neural network to learn complex relationships in the customer attributes. So neural networks, they are suited for supervised tasks with labeled inputs. So they can capture complex patterns, but they don't directly work on unlabeled data. The third option is to use k-means clustering to identify patterns among current customers and locate similar individuals. So k-means is an unsupervised algorithm. It's ideal for segmenting data without labels, and it efficiently can find groupings in such a data set. So this is a very good option. Then the last one, train a random forest model to classify new prospects based on customer characteristics. So the thing with random forest is that it's a supervised classification tree model. So it requires a labeled target variable. And since the data set is unlabeled, this approach is not applicable without first generating labels. So this option is also not correct. So the correct one is the third one. Question 11. A data engineering team is managing a large data set of images and associated metadata in Amazon S3 for a computer vision project. Each image has an associated JSON file containing metadata such as image labels and timestamps. The team needs to extract specific metadata fields, associate them with their corresponding image paths, and store the resulting dataset in a format that is optimized for large-scale machine learning training. Which is the most suitable approach? The first option is to use Amazon Athena to query the JSON metadata directly from S3, join it with the image paths, and export the results as CSV files to S3. So Athena can efficiently query the JSON data in S3, and it can also perform joins on the fly, but exporting the results in the CSV format is not ideal for machine learning workloads because it lacks compression and it's also slower due to the parsing performance. So it's not a good option. The second one, using AWS Glue to convert the JSON metadata to a CSV, join it with image paths using a custom Python script, and store the output in S3. So AWS Glue supports the converting and transforming of data, but using CSV and custom scripts, they increase the processing time and they introduce more manual steps. And CSV is not as efficient for machine learning as Parquet due to its row-based format. So it's also not a good option. The third one, using Amazon Athena with an AWS Lambda function to pre-process the JSON metadata and join it with image paths and then store the final dataset in ORC format in S3. So combining Athena and Lambda, that adds unnecessary orchestration overhead when a single service like Glue could handle it. ORC is a good columnar format, but Parquet is more commonly used. So this solution adds complexity without clear advantages over simple alternatives. And the last option, to use AWS Glue to catalog and transform the JSON metadata, join it with image paths, and write the output as Parquet files to Amazon S3. So this approach leverages AWS Glue built-in support for schema inference, transformations, and joining semi-structured data. Parquet is a columnar format that is well optimized for machine learning training due to its efficient compression and query performance. So this is the most scalable and most ML-friendly solution for handling large data sets in S3. So this is the correct option. Question 12. Which of the following statements is not true about Amazon SageMaker feature store? The first one, the online store retains only the latest feature values to support low latency real-time inference. This one is actually true. Then the second one, feature groups in feature store are immutable once created and cannot change schema. So this statement is not true because feature groups, they are mutable and their schema can evolve after creation. The third one, the offline store keeps all historical feature data in Amazon S3 for batch processing and training. This one is also true. And the last one, features can be ingested into feature store via streaming or batch processing. This one is also true. So the second one is the correct answer. Question 13. A healthcare company is developing a machine learning model on Amazon SageMaker to predict patient outcomes based on historical medical records stored in Amazon S3 as CSV files. The dataset is large, 100 terabytes, contains sensitive patient information, and requires pre-processing to handle missing values and normalize numerical features. The data engineering team needs a scalable solution to pre-process the data. Which AWS servers or combination of services should the team use to pre-process the large dataset in a scalable manner for SageMaker model training? The first option, use Amazon SageMaker Data Wrangler to pre-process the data, apply transformations, and export the processed data to S3. The thing is that Amazon SageMaker Data Wrangler is not designed for huge datasets like this one of 100 terabytes. So it's great for exploratory data analysis and small to medium data sets, but it could hit the performance and cost limitations at this scale, so it's not an ideal solution. Use AWS Lambda to pre-process the data in S3. apply transformations, and store the results in S3. This also, it's not suitable for large-scale data processing because there are hard limits. So we have the 15-minute timeout for Lambda and also 10 gigabyte of memory. So it's more a lightweight, event-driven tasks, and it's not ideal for this use case. Then the third option, to use Amazon Athena to query and preprocess the data in S3, and then store the preprocessed data in S3. This one is good for querying the structured data in S3, but it's not ideal for full-scale ETL. So Athena is less flexible for complex preprocessing. So it's better for ad hoc queries, but not for massive batch preprocessing. And then the final option is to use AWS Glue to crawl the S3 data, perform ETL transformations, and transform the data, and then store the results in S3. So this is a very good option because AWS Glue is serverless. It's a distributed ETL service designed for large-scale data processing, and it can easily handle those 100 terabytes of data efficiently. Glue also allows you to handle the missing values, normalize features, and perform other data cleansing tasks using Spark. Also, it offers encryption at rest and in transit. And also it integrates with AWS IAM, KMS, and CloudTrail. So you can also use it for sensitive health data. So this is the best option. Question 14. You're a machine learning specialist at a financial company with a dataset containing 200 variables related to customer transactions, such as transaction amount, frequency, customer age, account balance, and categorical features. Your task is to analyze the variance of these variables to identify and quantify multicollinearity among them without transforming or creating new features. As the original feature set must be preserved for interpretability in the final model, you are using Amazon SageMaker for your machine learning workflow. Which of the following approaches should you use to analyze the variance of the 200 variables and quantify multicollinearity while preserving the original features? The first option. Use Amazon SageMaker Clarify to generate a bias report and analyze the variance of the dataset by focusing on class imbalance metrics. So Amazon SageMaker Clarify, you can indeed detect bias in datasets and models, but it is not suitable for this task. So that's a clearly wrong option. Then the second one, use Amazon SageMaker Data Wrangler with Principal Component Analysis to measure the variance of the data along different directions in the feature space and reduce dimensionality. So Amazon SageMaker Data Wrangler with PCA, you can indeed analyze variance by transforming the dataset into a new set of uncorrelated principal components. But this transformation creates new features, which violates the requirement to preserve the original features for interpretability. So this option is not suitable. The third one, use Amazon SageMaker Data Wrangler with the variance inflation factor to measure multicollinearity among the variables and identify highly correlated features. So indeed, with Amazon SageMaker Data Wrangler, you can use the VIF to quantify multicollinearity by calculating how much the variance of a regression coefficient is inflated due to correlated features. And the VIF scores allow you to identify problematic variables while preserving the original feature set, thus meeting the requirements. So this is a good option. And finally, use Amazon SageMaker Canvas to automatically build a predictive model and analyze feature importance to identify correlated variables. So Amazon SageMaker Canvas is a low-code tool for building ML models. and it's primarily for business users. So while it can provide feature importance matrix, it is not designed for in-depth variance analysis or multicollinearity detection. So it is not an appropriate choice for this task. So the correct answer is the third one. Question 15. As a machine learning engineer working on a customer churn prediction project for a telecommunication company using Amazon SageMaker, you have a dataset with customer details, including the numerical feature monthly bill amount, which represents each customer's monthly bill and has about 5% missing values. After analysis, you confirm that monthly bill amount follows an approximately normal distribution without significant outliers, and the missing values are missing completely at random. Your task is to pre-process the data for a regression model to predict churn probability. Which imputation method is most appropriate for handling the missing values and monthly bill amount feature? The first one, median imputation. So this one is more appropriate for skew distributions or when outliers are present, as the median is robust to extreme values. So here we have a normal distributions and there are no outliers, so this is not the best choice. The second one, mean imputation. So this one is suitable for numerical features that are normally distributed without significant outliers. So that is the case in this one. So this will be a very good option. Mode imputation. This one is used for categorical variables, not numerical ones. So this is not a possibility. And the last one, KNN imputation. This one could be considered, but it's computationally expensive and unnecessary for MCAR data with a normal distribution, where mean imputation is simpler and sufficient. So the correct answer is mean imputation.